Right. In this lesson, we will be looking at factorizing algebraic expressions using the highest common factor. Now, you need to recall the distributive law. When we've got h multiplied into a plus b, it becomes ah plus abh. Similar procedure applies when we've got a minus b in the bracket. When h multiplies into the bracket is ah minus bh. And you can see that each term in the bracket is multiplied by the term outside the bracket. Now, let's do some example here. So, you can draw it if you like. 2x plus 5, 2x into 2 into x plus 5. We can actually do this. Draw it if you like. Using the distributive law, it becomes 2x plus 10. So the next one, it will be x squared plus 4x. And finally, the last one, 2x times x is 2x squared plus 2x times 3 is 6x. Right? Now, if you write the expression backwards, ah plus bh, which means we can factorize it. This, we use the distributive law to expand it. And this is called the expanded form. And this is the factorized form. And you can see that this here, h, is actually what you call the highest common factor, the HCF. So if we want to factorize this expression ah plus bh or ah minus bh, we know that we have to take the h and make it outside the bracket, put it outside the bracket. Now, the procedure. Important thing is to identify the highest common factor or HCF in the algebraic expression. For example, if we have 2x plus 10, you know 2x can be divided by 2, 10 can be divided by 2. Therefore, the HCF is 2. Now, we will take the 2 out and put this expression here in the bracket. Right? So, because we are taking the 2 out, we need to divide each term in the expression by the highest common factor. Therefore, 2x plus 10 factorized is 2 into x plus 5. You can check your answer by expanding, which is distributive law. Now, let's have a look at some example. Can we determine the highest common factor of 8a and 20? You know that 8a can be divided by 4 and 20 can be divided by 4 as well. So let's try it. 8a divided by 4 is actually 2a. 8a 20 divided by 4 is actually 5. Therefore, the highest common factor is 4. Now, of course, 2 is a common factor, but 2 is actually not the highest common factor. What about part B? 3x and 6x. For 3x, we can divide it by 3x, can't we? That equals 1. And what about 6x? 6x divided by 3x, that will become 2. So therefore, the highest common factor in this case is actually 3x. Now here, you've got 10a squared, which means it's made out of 10, a and a. And the second term is 15ab. It's made out of 15, a and b. You know that this is one of the common factor. And 10 and 15, the highest common factor is actually 5. Therefore, the highest common factor in this case is 5a. Let's check. 10a squared divided by 5a is 10a divided by 5a. Cancel that, cancel that. You have 2a. Alright? And 15ab divided by 5a. Cancel the a. 15 divided by 5 is 3. Therefore, it's 3b. So you can see that the highest common factor for 10a squared and 15ab is 3b. Now, applying that principle to factorizing an algebraic expression, let's have a look at 4x plus 12. Alright? You can see that 4x can be divided by 4 and 12 can also be divided by 4. Therefore, if I take 4 out, we can write down 4x divided by 4 plus 12 divided by 4, which means we now have 4 into x plus 3. If you want, you can check. Checking 4 times x plus 3 is actually 4x plus 12. Bingo, you've done it. What about number 2? Let's think about number 2. What can the highest common factor be? It can be 2, it can be 5, but in fact, if you looked at it, the highest common factor would be 10. So if I take 10 out, the first term will actually become 2, and the next one will become c. Right? Let's check it. 10 times 2 is 20. 10 times minus c is minus 10c. So that's correct answer. This is checking. What about the next one? 2x squared plus 8x. This time, both terms, they are x. And also, 8 can be divided by 2. So therefore, we can take 2x out. In this case, you've got x here plus 4. Let's check. 2x times x is 2x squared. Plus 2x times 4 is 8x. That's right. So you have factorized number 3. Next bit, I want you to take your time, pause the video for a while and try these 3 questions. Once you've done it, check the answer against mine. This time for 1. Okay? You can see that r is actually a common factor there. And 40 can actually be divided by 5. So therefore, we can take 5r out inside the bracket. 5r, if 5r divided by 5r is 1. Minus 40r squared divided by 5r is actually 8r. Let's check it. 5r times 1 is 5r. 5r times minus 8r is 40r squared. So that is correct. I checked it by distributive law. What about the next one? You've got a negative and negative. So in fact, both can be divided by negative 2. So if you take the negative 2 out, you will have 2x plus 1. Again, checking it. Minus 2 times 2x is minus 4x. Minus 2 times plus 1 is minus 2. So the answer is correct. What about the next one? Let's try. This time, 9 can be divided by 3. 6 can also be divided by 3. And both of them, they have x group. So, therefore, we can take 3x out. Now, here, that is a minus 9x squared. So, if we multiply 3x to minus 3x, we actually have minus 9x squared. And we need to multiply 3x by 2 to get 6x. So bingo. That is your factorized form of this expression. Now, again, I want you to pause the video for a while and answer these two. Factorize these two. Looking at the first one, you know that there's an x and there's y. So therefore, the pronumerals cannot be the highest common factor. In this case, the highest common factor is only 2. And therefore, this is x plus 2y. Right? Here is the same as well. The highest common factor would be 3. It's not x, it's not y, it's not z. So if I take the 3 out, it's actually x squared plus 3y minus 6z. That's it. So this is the end of the lesson. Factorizing by taking out the highest common factor.